All right. Hello. So stage three. So I just finished recording run, scrape, replay pipeline. So that was this pipeline. We got the replay JSONs from Book replays, and we saved that into our S3 bucket on AWS. Great. So the next step here is stage three. We're going to be now creating our deck type model. So modeling, this is data science stuff, and the deck type model that we want to make is given cards of a deck. I want to predict that deck type. So given, Thunder Dragon, Blacklisted Soldier, Fate, Dekoichi, all that shit, I want the model to predict that deck is Chaos Turbo, right? So that is what we're gonna try to do here. All right, let's close all this. And I think we could actually, okay, so first of all, so before we start doing the modeling, the first thing we have to do is actually get training data. All right. So we're going to get our training data from Format Library. So if I go to Format Library here, all right. So if I go to Format Library and I go to Decks and I click on Goat, whoops. If I click on Goats, there's about 1,700 Go Format decks. All right. If I clicked on one of these, it'll give me all the cards of this deck, main deck, side deck, all that, and some other information. Cool. So the plan is I'm going to scrape all these decks, all 1,700 publicly available decks, and yes, and then I'm gonna save those into a table here. I'm gonna save that into this table called event decks. All right, you see here. So I had to publish that. This is from Format Library whenever this deck was published. I had the deck type. I actually ended up saving both main and side decks, so that's why I created this deck type column, and I've relabeled. Deck type and deck class are going to be kind of interchangeable throughout these series. In this case, it's going to be a deck class in this whole stage. I'm going to be calling it deck class, all right, as in whether it's Warrior, Chaos Turbo, or something. All right, so from Format Library, the deck type, whether it's a main deck or a side deck, deck category from Format Library, of course, aggro, control, whatever. Deck class, Warrior, Chaos, Control, whatever. Card name that I've scraped from the the deck, and then also the card amount, the ratio of the cards from that deck, the deck builder, the event name, the placement of that player, and then the URL of the API endpoint that I called to get the replay data, and then stuff from the base model that I talked about before. All right, great. So that's the table that you want to populate now. We're going to scrape that data, that deck data from Format Library. So let's go over here to scripts, and it's called run scrape deck pipeline. All right. So if y'all recall from the past video in our run scrape replay pipeline, we had a pipeline structure that's newer than our Excel and Discord pipelines in the sense that we are implementing now AO meter for concurrent management and recent tenacity for retry mechanism. So if you're unfamiliar, definitely recommend checking out the last video. But that said, this pipeline is going to follow a very similar structure. Just to rehash that, in this pipeline script, we have this run pipeline entry point function. All right, this pipeline is an async pipeline. This whole thing is asynchronous, and it's going to be called here whenever this script is run. All right, so this is the entry point function. So we have our run pipeline function, and after doing some settings, some configurations, and setting up the HTTP client, and then the dueling book session or the database session. After those things are done, it sets some things up, and it'll run this AO meter, run on each function. And what this does is that I have this process deck wrapper. So this is a new wrapper. Again, I'm kind of brushing over it, but I talked about it in depth in the last video, the structure of this pipeline. But basically, this concurrent manager, AO meter, is going to take this function, process deck wrapper, and it's going to run that. This is like a for loop for asynchronous tasks. So it's going to for loop this. It's going to for loop this function based off these arguments, which is deck IDs. All right. So it's going to for loop that. But AO meter is kind of convenient whenever you're doing that kind of stuff with asynchronous tasks because you can actually control how much asynchronous task you want to run at one time. So maximum at once, max concurrency. and then also the rate at which these things are running. So how much jobs you want to run per second. All right. So just to rehash that, run pipeline function. I'm going to set shit up so that I can eventually run this AO meter concurrency manager. I'm going to run this function over and over again, given deck IDs. All right, and that's what this function is. Cool. So now let's talk about this process deck wrapper, the thing that we're actually going to be running over and over. So what this function is, it is a wrapper. So this thing right here. Process deck wrapper is actually a wrapper of a process deck function. So, okay, we see here process deck wrapper, all right? This is the function. It basically wraps process deck with this try except handler. All right, so so the process deck logic is actually in here. Okay, so process deck functions right here. And I talked about why I have a wrapper, but the TLDR is that this decorator right here, it's a retry decorator. It handles all retry logic, and that's from Tenacity. And whenever the retry hits its maximum attempted, like once the retry hits its maximum retries, it'll throw this retry error. And to capture that error and handle it, I have to wrap this in another function. All right, cool. But the actual logic for processing decks is in this process deck function. So let's look at this function. So this process deck function takes in the extractor, takes in the transformer, takes in the database session, and the deck ID. And with those, it will extract the deck from format library with this extractor. And then it'll transform that deck to put it into the format that we need to put it into our database with the schema that we've kind of went over. So once we have that transform deck, then if there is a transform deck, I want to load that deck to the database. And that logic is in here. So load that deck to the database. So for each transform data frame, I'm going to replace pandas and A's with none because SQLite has issues parsing that. And then for each record in the transform data frame or row, I'm going to create this event deck model object with all the columns that we're going to have in the database and just push that into commit that into our database. Okay. Cool. So just to kind of rehash that, AO meter is going to run a for loop on this process deck wrapper. This process deck wrapper is a wrapper over process deck function because I needed to have a handler for the retry error. And then our process deck function is using, it has our pipeline logic. And it also has this retry decorator here from Tenacity so that we could configure things like after how many retries do we want to stop retrying? After between retries, how long do I want to wait in seconds? And then are there specific exception types that we want to retry on? And then logging. Okay, great. Alrighty, so let's start from the top here on the run pipeline function. Let's actually look at this line by line now. So total pages, this is the total number of pages I want to scrape from format library. So if you go to format library, there's I don't know how many pages here. There's 166. But if I put this on 100 decks per page, it gives me 77 pages, all right? So that's how I get the number. All right, cool. So that's cool. So for 17 pages, given a parameter of 100 decks per page, next thing I'm going to do, I'm going to set up these context managers or this context manager, yeah, with the HTTP client and the database session. And I'm going to initialize the extractor and transformer. All right. So I'm going to initialize these so that I can use them in the process deck wrapper later. And what the extractor is going to do is going to extract. So for example, in Dueling High, it's going to extract this data here. All right. It's going to extract that data from each deck. And okay, so it extracts from each deck, but it also extracts from each page. So the extractor does two things. It extracts all of this data here from each page, and then from each deck in this page, I'm then going to make another request to this URL, which I could then get this actual card by card information for each deck. All right, so it's two extractions here. All right, so I initialize the extractor here, and that's his jobs. And the transformer is to, take this raw data from the extractor and, transform that into the transform data frame for our database table. All right, next. So now we're going to go through each page number that we've defined here in total pages. So for each page from 1 to 17, I want to get the page of decks. So for each page, I want to get all the decks of that page. And let's see how that looks like. So get page of decks. So this is the extractor. Very, very simple class here. Less than 50 lines. It has two methods, two public methods. They're just HTTP requests. All right. So this first method that we're calling get page of decks is going to. So I didn't go over the configuration, but there's not much configuration here. Basically, I give it the format library URL. I'm going to specify what page to make the request. Page number 1. I have the limit. I have the limit here as 100, which means for each page, I want a limit of 100 decks per page. And I'm sorting it so that it's for GOAT format, it's from descending order, and all that stuff. All right. So this is the URL that I want to make a request to get a page of decks. So then I'm going to make the request. So I'm going to call my HTTP client, and I'm going to make a GET request to that URL, and then I'll have the response. If the response does not give me a 200 status code, then erase it as an error, erase for status. Otherwise, I want to turn the body, the response of that, the body of the response, I want to turn that into a JSON Python dictionary and return that to me as a list of dictionaries. Because I'm not going to pull it up just because like all these websites with advertisements on them, their network pages is so cluttered of garbage and the waterfalls are really bad that I don't want to go through that. But the TLDR in this page has 100 decks. So it'll give me a list where each dictionary is information about this deck. And that information might be format GOAT, deck type warrior, builder, this guy, etc. But more importantly, the reason why I'm making a request to this page to get this 100 decks is because each record has their deck ID. And with that deck ID, I could then make a separate request to this page. And this page with the deck ID would actually give me the data that I want, which is the card by card data. All right, cool. So get page of decks. So now I have a page of decks, right? A list of dictionaries. So now I have page of decks. Now I want to go through each dictionary or each deck of that page. I want to get the ID key because this ID is the deck ID that I was talking about. So I'm going to get the deck ID from all decks of that page. I'm going to have it here as a list of strings or a list of integers, actually. Yeah, because I turned to an integer. All right, so now I have a list of integers of deck IDs. This is the argument that we're going to be looping over in our for loop. All right, cool. So now we have our deck IDs. And next thing we're going to do is run the AO meter manager. So now I'm going to run this process deck wrapper. I'm going to give it the extractor and the transformer and the database session. And the arguments are the deck IDs. All right, so for each page, I have 100 deck IDs, and this manager is going to be responsible for 100 IDs. So now let's actually look at the process deck function. Okay, so this process deck is going to take in that deck ID, and it's going to call this extractor get deck, right? So it's going to get the deck for this deck ID. If we look at the code here for that, it's going to take in that deck ID integer, and it's going to construct the URL for that. And then it is going to make a GET request to that, URL. It's going to give me a response and give me that response as a dictionary. Same logic as the get page of decks method. All right, cool. So what this does is that it gets the API response as a dictionary for each deck ID. So now I have the deck data, and this deck data is in a very raw format, is in whatever format FORMATLIBRARY has it set up as, and I want to transform that into a tabular structure for our transform data frame to load into our database. So I'm going to take this deck data, which is a dictionary, and I'm going to put it into our transformer now in this public method transform deck data. And with that, I'm going to give me that event dex data frame. So let's look at that. So this is our deck transformer. So it takes in the deck ID and the deck data, the dictionary that we just had. It's going to output me the transform data frame. So first of all, I validate the deck data. I want to make sure that this is what I want. And if I look at the deck validator, it takes in the deck data and it makes sure that it's a dictionary. And it also makes sure that the response has these keys. This main key is going to have the actual main deck cards. The category is going to have whether the deck is aggro or control or something. And deck type name is going to have whether that deck type name is Chaos Turbo or Warrior or something. All right, so I need these keys because this is the data I want from this deck. So it's going to look through the keys of deck data and ensure that this data is here. And once the validator is done, cool, we're moving on to the next step here. So deck validator is done. This deck data has what I want. So then it's just a matter of cleaning and structuring the data in a way where it gives me this dictionary of this data right here. So first of all, I get the publish date, I get that, clean that. And then afterwards, I get this base deck data. Okay, so we're going to do a loop in a second, I think. No, I'm tripping actually. So base deck data. So again, I'm storing data for main and side. So for each main and side, they're going to have these same columns here. So it's going to be publish stat, deck category, deck class, deck builder, event name, event placement, and the URL, which I am just going to properly construct here as, FORMATLIBRARY.com, API decks, deck ID. Cool. So this dictionary is going to be consistent for both the main and side cards. So the next thing I'll do now is I'm going to call this create deck rows method. And you can see that is down here. All right, so I'm going to go, here. So we have create deck rows. This is going to take in the data from the main key of the dictionary. This will have our, main deck data. And we're going to specify that, this is for the main deck. And this is the base deck data right here. So I wanted to also include this data for each row in this main deck data frame. No, in this list of dictionaries. So for each dictionary in this list, I wanted to include base deck data. I'll probably, no, okay, it's fine. So create deck rows, I do this for both the main deck and the side deck. So if we look at this again, so again, it takes in the cards. So remember how I made so I got the main deck cards from the API. So that cards, it looks like a list of dictionaries. Then I specify whether the deck type is main or side. And then I have the base deck data as dictionary that I also want to append into each dictionary record here in this array. Okay, so I'm going to actually get the name for each card, and I'm going to get the card name, card amount, deck type, and then I want to spread out the base deck data in this dictionary, and then just have it all into this array here of cards of this deck. All right. So what this would result in is a list of dictionaries, which is like a list of card names with their card amounts for the main deck and the side deck. Once I have the main deck and the side decks, then I'm going to concatenate them. Actually, I think this, so this combines these arrays together. And I'm going to run this pandas data frame function to turn this into a pandas data frame. So now I have this transform data frame of the main deck and side deck. Great, and I'm going to return that. All right, so that's the deck transformer. So just to recap this process deck function, I've extracted the deck data from the deck ID endpoint. And then with that data, I transformed it so that I could get this structured transform data frame with the main deck and the side deck. And if the transformation went well and the validation passed and I've actually returned a data frame, then I want to load that data, that deck into my database. And that's this function right here. I'm going to go through each row and I'm going to fill out these values. And I'm going to commit that to the database. And that's the end. All right. So for each process deck function that's extracting, transforming, and loading to the database, I'm going to run this thing for each 100 decks per page. And this will loop through each page where the end product would be a database. Where the end product would be this, right? So deck type main, if I scroll down, this is the same side for dueling high, right? All this. This is what we have now, right? And we have 61,000 rows here, right? So this is all 1,700 decks, I think. Let's see. Let's select all from event decks. Actually, no. I won't call it URL. Not this thing. I ain't gonna lie. All right. Well, fuck it. We gotta look that up, I guess, but it's fine. Uh, So that is all the decks there. We're gonna go back to our folders here. We'll go back to our pipeline, and so that data is now available there. Great. Uh, so that's the end. So now we have our training data. All right. So our training data is from my library, and the idea was I'm gonna say this again once we go to the actual notebook. Our first notebook actually of the series, our deck type model notebook. But whenever I go there, I'll talk about why I did all this, the extraction from my library and everything, and just to kind of summarize it. The main reason was because I assumed that a quality of format libraries deck type classes would be an appropriate and acceptable standard to do predictions on. Okay, so that was the reason why I scraped from my library. I pretty much had the assumption where, as training data, people are pretty satisfied with format libraries definitions of deck type. No one really questions it, right? And so I figured that if I train the model on that, then I'm essentially having the same, whatever system, format library uses to classify deck types. And I figured that'd be acceptable. Okay, so that's why we scrape this data from my library. We're going to use that as training data. And now on the next video, I'm going to go through our first notebook where we talk about some data science and build out a pipeline for a classification model for deck types using cards. Great. All right, that'll be the end.